Hello everybody, today we have a NetGear ProSafe 24 port 10100 switch. The model number is JFS524. I picked this up from a site. We got a call on a Monday morning to say that half of the network was down, so I pretty much had a good idea that it was a switch. So I called the site and the switch had about as many lights on as it does in this photo. So I pulled it out. It's only a 10100 switch, so we use it as an opportunity to put in a 1 gig switch instead. And I took it away with me. Now, this obviously is not really worth fixing, but just for a bit of practice, I decided I'd take off the cover and have a go. And you can follow me along on this. If you have any comments or anything to offer, please post down below. Let's go. So this is my Netgear switch with the hood off. We have two discrete boards here. So what we have is on this side, we have where the power comes in. That's this little board here. And then we have one cable that feeds this main board here that is obviously the nuts and bolts of the switching operation. So what do these boards do? Well, first of all, we have our mains voltage coming in here. This little board here, as we can see from the top of it, I hope it's clear there, that accepts an input of 100 to 240 volts. That's so that it works in both the States and in Europe. And the signal at 50 to 60 hertz. So that's an AC signal on the input, and it gives 5 volt DC at 3 amp on the output. That's this connection here. So the sole purpose of this board, you could call it essentially a generic power board. There's nothing unique to the function of this switch about this board. This essentially breaks the mains voltage down to 5 volts, and that 5 volts is then fed across 4 wires. So you've got ground, ground, 5 volt, 5 volt. Let me just show you that. So you've ground, ground, 5 volt, and 5 volt, which is fed to this main board here. So what we're able to do with this is we're able to split the problem in two. So we know that this board should have 5 volts on the output, and we know that if we have 5 volts going into this, whether from this power supply or from a desktop power supply, then this board should power on. So what I'm going to do first is I'm going to separate the cable by magic, and I'm going to measure the voltage that's coming out of our little power adapter and see if we're getting 5 volts there. If we are getting 5 volts there, then it's likely that we have a problem with this board here. And obviously, if we're not getting 5 volts on this one here, then it's likely that the problem is somewhere here. So let me bring you through that. Okay, so what we want to do first is measure and see that there's 5 volts coming out of this board here. So what I'm going to do is I'm going to introduce my voltmeter, and we're going to put it on volts DC and put it in the 20 volt range. And I'm going to get my black probe, and we're going to place it on where the black wire is here. You just need to be careful with this. So you actually need to shove it into the pins. I can't do this in 3D here, but you need to come in down and press it into one of those black wires. Then we get our red wire and place it into where the red wire comes out. You can also measure it up here, but that will keep moving around. I don't want to measure it plugged into the board in case there's something on this board that's toying with it. We can separate, when we have this plugged out, I can measure the voltage here without this board having any effect on what voltage is coming out of this. So with those two pins connected, with the two probes connected to those two wires, I checked it there, and what I found was that there was 5 volts DC coming out of there. So that board is working. Now, I wasn't really expecting that, because a lot of the times when there's an issue with these types of devices, it's this power board here that the fuse is gone, or a transistor or something has gone on it. But in this scenario, we had 5 volts coming out of it. So we could perfectly, validly use this as a 5 volt for powering another 5 volt circuit, and it would work fine. So the question then is, what is wrong with this board? So to try and find out what was wrong with this board, the first thing I wanted to do was inject 5 volts from my own desktop power supply into this board and see what happened. And that's what I'm going to do next. So we're pretty confident that the 5 volt is good from this point. So just to reiterate, we know that we've got AC mains coming in here. We know it's getting broken down to 5 volt DC, and that 5 volt DC is on these wires here. But just in case that the 5-volt supply is failing when we plug it in, I'm going to supply this board with an alternative 5-volt source. Well, you're probably saying, how are you going to do that? Am I going to buy another one of these boards, or what am I going to do? But it's actually quite easy in this case. If we zoom in at these pins here, the question is, what exactly are we getting from the other board? And if you look at this, we're getting 5 volts, 5 volts, ground and ground from these 4 wires to these 4 pins. So with my desktop bench power supply, I can introduce 5 volts myself and see what happens with this board then, and see if it powers up. I suspect that it won't, but we're going to see. So what I do here, I'll just get rid of that little banner. I have a desktop power supply, so I switch it on, turn it to 5 volts DC, and with a maximum current of 3 amps, which is what the same as the other one provides. That's just in case that there's a short. It has protection built in anyway, so there's nothing really to worry about. So I get my power injection probe, and what I'm going to do here is I'm placing the red one in between the 2 pins and connecting to both pins at the same time. That's with my positive pin from my power supply, and with my black probe from my power supply, I'm going to touch it off the 2 of these pins here. So we're essentially emulating what this board is doing. And unfortunately, when I touch these off the pins, absolutely nothing happened. So I was pretty sure at that point that, that the issue then was with this board and not with this one. So when I was looking closer, I then spotted this. You probably spotted yourself already. Actually, just see if you can spot it before I point it out. It might be of value. Okay, in 3, 2, 1. This chip here, I didn't know whether that was the marking on it to show you where pin 1 is, because normally in the top corner there's a little circle that shows you where the pin number 1 is for any particular chip. However, these two, the chip here and this chip here, are exactly the same. So when I looked at this one, there was obviously no marking on it, and I got my digital microscope and zoomed in on it. And you'd probably be able to see it from this, even though my picture is not so good, that this part of the chip was blown out. So there is an obvious fault on this board. I don't know if you can see it from here as well, but that capacitor looks to have vented also. Now, unfortunately, this chip I didn't have a quick replacement for. So just because I want to have it, just because I want to try and fix it, I've ordered this from AliExpress. Now, as you know, when you order from China, it's going to take quite a long time to arrive. But I'm just going to do it just to see if I can get this thing back up and running. So there may well be a part 2 on this. But I hope that it gives you some guidance to the approach that I take when dealing with these sort of boards. It's actually easy enough to split it up, and as in this case, it's not always that, if it's broke, that both boards will be blown. It's usually that one is blown, and then if you replace that board, or for example, if this 5-volt board was blown, what I would be able to do is get just a generic power adapter and connect it to these wires and put it in here, so long as it had enough current. We could get another 5-volt 3 amp supply, hook it into this here, and power this back up again. Unfortunately, in this case, it's this actual board itself, and I'm not going to have a spare one of these boards around. It's just not going to be the case. And even with that chip, I don't do a lot of switches, so I don't know if this is a common chip or not. But I don't have one of these chips around either. So that's on its way from China. When it arrives, I'm going to replace that chip, and I will have a follow-up video then to hopefully show you how I fixed it. If you have any comments, positive or negative, anything at all, just post it below. Thanks for watching.